Hey guys, today the plan is you should first check your answers to the homework from page 13 and 14 that you did over the weekend. That's on the other Zoom video. And then today all we're going to do is the practice problems that relate to potential energy diagrams on page 17, 18, and 19. So you're not going to have a long thing to listen to. I'll post the answers so you can mute me, but if you want to hear the explanations for all the problems, you can do that too. You are going to have a Google Classroom homework assignment, so you should, it's going to be related to the page 13, 14. So make sure that you look at that first before you do the homework for tonight, okay? Okay, so let me share my screen. So actually, you should pause this video and you should do the problems, multiple choice problems on page 17, 18, and 19. And then page 19 has another set of problems that are kind of tricky. And I can give you a hint for those before you start them if you want. Okay, let's get started. Okay, so question one, number one should be an easy one. Exothermic reactions always release heat. Question two, these questions are always hard for people. So as a result of dissolving a salt in water, it's a beaker, and that's for your salt, the temperature of the water went up. So because the temperature went up, the water had to be getting heat from something. So the salt was releasing energy, meaning it was exothermic. So dissolving of the salt is exothermic. Number three, delta H is always equal to heat of products minus heat of reactants, or the difference between products and reactants. So that's what you want to look for letter A. All right, number four. Okay, so in number four, salt was added to a beaker and the temperature went down. So that means the salt was taking heat from the water, endothermic. And then letter B is just like this one. The salt was giving heat to the water, exothermic. So the answer is C. Did this the other day. Okay. Okay, so moving along. Number five. Okay, so number five, in a reversible reaction, the difference between activation and this one's also hard. Okay, difference between activation energy of the forward reaction, which is right here, and the activation of energy of the reverse reaction, which is right here. So basically what it's saying is, if you have these two arrows, so like this long one, this short one, what's going to make up the difference? So the difference would be this space right here, right? So if I have this space right here, then these two arrows are exactly the same. So if I subtract these two, this is the space that's missing. The space that's missing is always your delta H. It's the one that's not touching the top, not touching the bottom. So the one smack dab in the middle. Number six, difference between potential energy of products minus potential energy of reactants is your delta H. Delta H is called heat of reaction. Okay, this one, number seven, they try to trick you on this one. So which statement describes the reverse reaction? So going in the forward reaction, you have heat being added. That is endo. So I have an F here, forward equals endo. That means the reverse has to be releasing exo. Number eight, which statement best describes a chemical reaction in which energy is released? Exothermic. negative delta H. If you can't remember that the delta H is negative, look at table I on the very bottom, and it says negative delta H indicates an exothermic reaction. Okay, so number 9, which arrow represents activation energy for the forward reaction? Right there, letter B. Number 10 is a lot like number 7. So going in the forward reaction, you have heat on the right, exo. And then in the reverse reaction, heat is entering, so it's endo. Forward is exo, reverse is endo. Let me close the door, hold on. My kids found the toys that I've been going to donate, so now they want to play with them, which is perfect. Okay, number 11, exothermic reaction in a water solution means you're dissolving something. So if it's exothermic, that means the salt is giving off heat. So if the salt gives off heat, the temperature of the water goes up. Choice A. 12, in what type of reaction do the products of the reaction always possess more energy than the products of the reactants? So that is saying these have more energy because these are your products and these are your reactants. Okay, number 13. Let me just scooch this down a teeny bit. Okay, so number 13, which letter represents activation energy for the reverse reaction? So this is activation of the forward reaction, which is letter A. They just scooted it over. This is reverse activation. Which arrows would be affected by adding a catalyst? So a catalyst comes in and lowers the hill. So what arrows are affected by this hill being lowered? A, this arrow, and also this arrow, B. All right, and then moving along to the next page. Okay, for number 15, which letters represent activation energy of the forward and reverse respectively? So this is the forward one. The reverse is usually here. Oops, that was not a good line. The reverse is usually right here. Not much better, but you get the point, which is represented by this letter. So that's one way that the regions can trick you around, is that they can move the arrows around, but it's still the same space. So just be careful of that. And then 16, in a potential energy diagram, the difference between the potential energy of the products and your reactants. So this is just saying heated products minus heated reactants, and that is equal to your delta H, which is heat of reaction. And then 17, the activation energy required for a chemical reaction can be decreased by adding a catalyst. That should be easy. Okay, so let me stop this share and go to a different, I'll pause the share and go to a different page. Okay. All right, so if you're feeling like these questions are kind of hard, I think they're a little tricky at first. Don't worry about it if you're not doing the best, you'll be fine. Okay, let's go through and talk about this graph before we even do any questions. So looking at this graph, one thing that they didn't do was they didn't give you the line that's usually here. These are your reactants. I guess that's too thick. do it like this. Okay, so this right here, your starting point is your reactant. These are your products. Okay, so arrow B, the one that does not touch the top and does not touch the bottom, hey bud, is your delta H, enthalpy or heat of reaction. What arrows represent the total energy of the activated complex? Okay, so activated complex, what do you get in, my man? Is right here. It's at the top all the way to the bottom. So A plus B plus C. Bye. Okay, the forward reaction. So you start at 90.
Mommy, are you talking to yourself?
Yeah, you got it. I love talking to myself. Start at 90 joules and it goes down to 40. So heat was released. So that means it is exothermic. Which arrows represent activation energy of the reverse reaction? So reverse activation is from the end up to the top line. So what arrows make that up? We have letter A and B. Okay, I'm going to erase some things now. I probably shouldn't have done that. Oh well. Hopefully you got that down. Okay, reactants are here. What arrows represent the energy of the reactant? So I think it's handy to like draw in where they normally are and then see what makes them up. So B and C. This is harder than what you'll see on a Regents exam, just so you know, if we have a Regents exam. Who knows? Okay, what is the numerical value of heat of reaction? So delta H is heat of product minus heat of reactant. Okay, so these are your products. So you read over 40 minus reactants, 90. 40 minus 90 is negative 50, and it probably is kilojoules or something like that. 24, what is the numerical value of the activation energy? So letter A is activation energy. So you start at 90 and you need to get 110 for the reaction to begin. So that is 20. What is the arrow of the energy of the product? Right here. So that is the same as C. What arrow is affected by a catalyst? Catalyst comes in and lowers the hill, so you can see it just cuts that letter A. Okay, and then 27 is a weird one. Okay, so what arrows make up the forward activation? So letter A is forward activation, although it is normally right here. All right, so A, what arrows make up the reverse activation? So reverse activation is here, and it's made of A and B. When you subtract those, what arrow remains? So basically, if I subtract these two, I end up with letter B. Okay, so I feel like this is a pretty tricky topic. What I might recommend is like changing, hold on, let me stop the share. Go to this instead. Is just practicing where they're normally located. So like if I were to give you this diagram, you should know right away if it's exo or endo. And then you should be also able to label all these arrows. The tricky thing is that the arrows can move position. Like I could have this arrow and this arrow are equivalent, but see how they're in different spots? And this arrow and this arrow are equivalent, but they're in different spots. So you kind of need to be able to really see the spacing. So you might want to just like practice a blank diagram or just use your notes and go back and forth, and you'll kind of get the hang of it after you start. Okay, that's all for today. See you later.